Finally, let's learn how to find inverse functions both algebraically and graphically. So the function is x squared minus 2. They are asking us to find the inverse. Well, does it even exist? It's a parabola that shifted down by 2. So it's looking like so. It doesn't pass horizontal line test, so it's not supposed to have inverse function. But this small notation fixes the problem. They actually tell us that we're only looking at half of the parabola, from 0 to infinity. So that piece actually passes the horizontal line test. Since it passes the horizontal line test, inverse exists, and we can find that y equals x squared minus 2. We are looking for x. Solve for x. That means let's isolate x first. That will be y plus 2. Then x will be plus or minus a square root of y plus 2. Since x is required to be positive or 0, we will not consider minus in this particular scenario, but in general we should consider both. So this is my inverse. Let's rename it. Rename. The name of the inverse will be f minus 1 of x is a square root of x, not y anymore, x plus 2. What we're doing here, we're renaming x and y input and output, because that's exactly the idea of the inverse functions. We are looking for the input instead of the output. So these two functions are inverse to each other. The domain of this function, well, that's actually the next question. Let's answer it right away. It's going to be C, question C. C says find a domain and the range. So they don't for both functions. Let me do it here. So domain and range. Let's see. For the original function f, which is x squared minus 2, where x should be greater or equal than 0. The domain is exactly what they told us, from 0 to infinity, or just x greater or equal than 0. The range, though, is all the possible outputs. If I start drawing the function, here it is, in green. This is the half of the parabola. The parabola is shifted down by 2, so y equals x squared minus 2. The range are all possible outputs. So as you can see, it starts from minus 2 and goes to plus infinity. That is the range. Minus 2 and plus infinity, because it is shifted. But for the inverse function, let's put it in blue. F inverse is a square root of x plus 2. The domain becomes a range, so it's going to be 0 plus infinity. And the range becomes domain minus 2 and plus infinity. Let's check it graphically. Remember how we draw inverse functions? I first draw a helping tool. Y equals x. Y equals x, and using it as a mirror. That makes sense because we're flipping y and x, so that's why we're using this as a mirror. And reflecting the existing function f to get f minus 1. Let's see, it used to be minus 2 on the y-axis, now it's minus 2 on the x-axis. Then this is the point where they intersect, and then this is used to be a 0 point at, so, and now the new 0 is over here. So all the points are flipped, and this is my inverse function, which is a square root. We know how the square root looks like. This is a square root shifted by 2 units to the left, using the graph transformation. What is the domain of this function? Well, as you can see, the inside of the square root should not be negative. So x is required to be greater or equal than minus 2. Makes sense, it's exactly like this on the graph. That is my domain. The range is from 0 to plus infinity. Let's check. Domain is minus 2 to infinity. Range is 0 to plus infinity for the inverse function. Question B asks us to draw both graphs, and here they are. You can draw it either using the understanding of the graph transformations. The first function was shifted down by 2. The second function is the square root function shifted to the left by 2. Or you can use the reflection idea, just like I did, y equals x, and then you reflect the quadratic function using equation or line y equals x, using it as a mirror. And that's how you work with the inverse functions. That's how you find them, draw them, and also analyze their range and domain. Thank you for watching.